Hello, this is Stephen Whitfield with Drilling Contractor. Today I'll be speaking with Matt Boerlage, Product Director of Control Systems at Baker Hughes, about the company's recent developments in BOP technology, including validation testing performed this summer on its CPrime BOP control system. Matt, thank you very much for joining me today.
Of course, you're welcome, a pleasure.
Let's start with CPrime. Now, a couple of months ago, Baker Hughes completed validation on an updated version of the system. Could you explain what this testing entailed and how does the updated version of CPrime differ from the version that was initially launched a few years ago?
Absolutely. So the testing was a long campaign that we were under. So we designed CPrime using design for reliability. That basically means that we have reliability requirements that we flow down to individual components and subsystems. But at a certain point in your development, you really have to verify all those requirements. So about 5 years ago, we designed and built this extreme event flow loop test system in Houston, and we have been testing a fully functional CPrime pod for the last 5 years. So a month ago, we completed that testing campaign, and not only did we verify that we could exceed the 99% drilling availability requirement, but we also collected over 300 years of life equivalent data. And with that data, we're able to launch CPrime from day zero with condition-based maintenance. So what is different now in this CPrime from the ones that we have shown to the world earlier is that in 2016, we made the CPrime dedicated for a 20K PSI stack. And we used all the footprint that was available on the stack to make everything as easily accessible as it could be. There we had this idea of the inside-out design philosophy. That basically means that all the serviceable components throughout the whole life cycle of the pod need to be accessible from the outside. That is, of course, helping with the quick time to repair and service planned serviceable components, but it also eliminates any collateral damage that you typically see on control systems in the industry. Collateral damage is a main driver of downtime across our industry. So we want to keep that design philosophy, the inside-out design philosophy, but then we also wanted a small footprint. So we spent a considerable amount of engineering to really squeeze down and shrink down that package to now a footprint that we can use the same control system, the CPrime control system, with the inside-out design philosophy, but then on any 15K PSI stack. So now you get the CPrime technology on a 15K PSI stack. And that's a major achievement of our engineering team.
CPrime comes with a reroutable smart redundancy feature that Baker Hughes has said helps reduce BOP downtime. Could you explain a little bit how this feature works?
Absolutely. As I was just saying, we started with design for reliability. It's a really good way to analyze failures, reliability, and inherently in the product. And once we started with this program, we discovered that all industrial control systems for blowout preventers have a lot of single points of failures. And these single points of failure are a major contributor to downtime across the whole industry. So using our analysis tools, we then also discovered that it was a very short putt to make a fault-tolerant control systems architecture. And what that basically means is that the driller can isolate the fault and then recover that functionality from that failed component while remaining subsea. And we have a patented approach on how you include that in a BOP control system today. And we were able to show that we can prevent 80% of the traditional stack pools using this fault tolerance. Now that is a major game changer for our industry right now.
Are there any other areas of BOP tech development that Baker Hughes is focusing on at the moment?
Oh, absolutely. Yeah, we just finished our design on the 20K BOP. So now it also passed all the third-party verification. It is a BOP with an 18 3/4-inch bore diameter, and it is rated to 350 Fahrenheit. So we have 6 rams, 2 annular stacks, and approximately a footprint of 20 by 15 feet. So the design has been around since 2012, but now we have a completely verified prototype, and it is available for production.
Well, Matt, thank you very much for speaking with me today and giving our listeners some insight into the work that Baker Hughes is currently doing in the BOP space. Thank you.
Thank you. Thank you. Pleasure. Thank you.
And thank you very much for visiting Drilling Contractor.